There we go. All right. I guarantee I'm the last talk of the day. Thank you, everybody, for sticking around. My name is Robert Simmons, and I am the Director of Research Innovation at Threat Connect. We're based out of Arlington, Virginia, so this is not a local company to France. But I also go by the nickname Utkanos, which is duckbill platypus in Russian, and that actually goes back to a nickname I got from when I was learning Russian in college, and they made us pick a Russian name for while we were in class, and so I think if there are any Russian speakers, you'll get the joke here. My name was Alexander Cheburashkovich Utkanosov, so a couple of laughs maybe. So to start off, I want to go over some basic definitions first. And so what we're going to talk about today is developing a program of threat intelligence, and so ways to do hunting to find threats to actually feed a threat intelligence program. So there are a couple of different types of threat intelligence. There is tactical threat intelligence, so this is based on learning the attack patterns or the TTPs of an attacker, attacker methodologies, their tools, and their tactics. That's not what we're going to be talking about today specifically. There's also operational threat intelligence, which is the details of a specific incoming attack. You could develop this type of operational threat intelligence by looking at chat log captures, looking at forums, and this sort of thing. This is also not what we're going to be talking about today. And then you have strategic threat intelligence, which is high-level threat intelligence, which can involve risk and looking at changing risk. And this is the type of intelligence which is basically aimed at management and aimed at the upper levels of the company so that they can make strategic decisions. But today we're going to be talking about technical threat intelligence, which is indicators of compromise, gathering data from various sources in the operational environment, and then baking them down into threat intelligence that you can then either publish or use inside of your own organization. So I know this is one of the government slides where it has not a very, it's not a very good picture, but it's very effective in telling you exactly what the intelligence process is. So you have planning and direction, and then you have collection. The next stage is where you process and exploit the intelligence. The next stage is going through analysis and production, and then dissemination, sending out reports or delivering reports to your customer or to your superiors. So another way to look at the intelligence process is by focusing the data that you get from your operational environment down to something that can be consumed and interpreted in the form of intelligence. So one of the lenses that you use is collection. So you have lots of information out in the operational environment, and then you collect some amount of it, and then you have the data that you've collected. You have another lens that you process and exploit that information, that data down to information. And then you have analysts that look at the data and analyze it and produce intelligence from that information. So there's a concept from David Bianco's Pyramid of Pain where the different levels of the Pyramid of Pain, when you take this away from the adversary, it kind of equals how bad of damage you're going to do to that adversary's campaign or whatever they're targeting at that particular point. So hash values are very easy for an adversary to change. You can just recompile your malware, recompile your implant, whatever you want to call it, and you get a new hash value which is then not detected. You can go for some of the more difficult or targeted hash values like an import hash, etc. But still, it's still hash value. You can adjust your build and then evade things that work on hash values. Then IP addresses. IP addresses are very cheap. You can move around from an IP address to another IP address very easily. taking away a particular IP address on a virtual private server or something like that is not very painful for the adversary to correct for. Then domain names, as we've seen, domain names, there's a lot of domain generation algorithms out there right now. Adversaries will, create domain names, but the domain name space is smaller, and so finding a new domain name once one has been taken away actually takes some form of money, unless you're going to use something like freenom.tk, where you get free domain names. But for the most part, you have to actually spend money, so there is a bottleneck there. And then network and host artifacts. So this is actually looking at signatures that you can find on a host or signatures that you can detect on a network. So this would be something along the lines of a signature for a host-based intrusion detection system, network intrusion detection system, signatures of various types, and then figuring out a particular tool. So finding the attack pattern involving a particular malware family and understanding and being able to detect that malware family, that taking that away from an adversary is very challenging. And then taking away an entire attack pattern or a TTP is the toughest thing to do. So the concept of what I'm going to share with you today is a process. I know we've watched a lot of very technical talks. This talk is not going to be very technical. This is going to be more process-driven, and I want to actually share the process with everyone because I think the inverse pyramid of pain, if you consider the things that we as defenders of a network develop, the most effective thing for us to share and the most difficult thing for us to develop is processes. So I would say the inverse of a TTP up there at tough is developing an effective process down at the bottom. So I want to define the problem that I'm solving or attempting to solve. First part of the problem is we all have small teams. Well, some of us are lucky and have a large team, but most of us are small teams. My team is a team of 10. And also, hi, Eric, I'm sure you're out there watching. This slide did say team of 9 before last week, so we had a new hire, so he's just joined us in the past week. But we're still a team of 10, which is a small team. You need to be able to compete and fight above your weight class. And so to be able to do that, you have to use automation and intelligent, efficient processes. So the second part of the problem is you have limited resources. So I know a lot of organizations are representative in this room. You create paid feeds, and so you're generating this large quantity of data that someone needs to consume. And it's not always easy to consume this large quantity of data. You have paid feeds, you have open source intelligence feeds that you might just collect from various sources on the internet. And so depending on the quality of the feed and how many you're bringing in, there might be a high signal to noise ratio on that particular feed. It might be, there might be false positives. Some are better at false positives than others, et cetera. And then also another limited resource is your tools that you're using and your time. So when you have a automated malware analysis system, you have a limited amount of time that system can be running, and it has a limited amount of resources. So there are only n files that you can analyze with an automated malware analysis system. So you have to actually figure out a way to maximize the utilization of the tools that you have available. And then the third part is limited time. So if you have a team of analysts, you don't want that team of analysts doing manual labor. You don't want them just moving data around. You want them spending as much time as possible doing their primary job, which is analyzing malware and analyzing threats. So this is a couple of swim lanes that represent what my team was doing at the beginning of when I first arrived at Threat Connect, and this was a couple of years ago. And by the way, just to give you a little bit of background, the talk that you're seeing today is actually an evolution of a talk that I have given in the past. I first gave this with Rich Barger back at SANS CTI Summit in Alexandria, Virginia, quite a few years ago. And so this is an evolution of that same process. And I see people taking pictures of this one. This is not the one you want to take a picture of. This is the old process. So I've kind of categorized the left part of each of these swim lanes as the things that the analyst has to do manually, and then the stuff on the right is something that a computer or a system is doing for the analyst. And so on the left-hand side, we have the YAR hunting, which we do. Our particular location for doing YAR hunting is VirusTotal, which I'm sure a lot of you also do hunting there as well. But the concept here is actually not restricted to VirusTotal. It's using Yara to actually take a body of YAR rules and a stream of files and then take the results from them. So you have to update the rule sets in text files. So of course, one of the main problems is you have a whole bunch of rules, and how do you keep them organized? So that's a problem number one here that I identified. And then you have to copy and paste them to deploy them out to VirusTotal. And then you have the VirusTotal hunting system that gives you a bunch of notifications. And then you have to look through the notification emails. I understand that it is available via API, and we'll get into that. But most people are just reading through the emails that come out, and so that's the terrible way to work. And then you have to download the file, upload it to over here on the sandboxing side. You're then uploading your file to the sandbox. You then go get coffee and come back, and it'll be done. And then you look at the sandbox report, and then you have to analyze the sandbox data and then write an Intel report. So I'm going to show you in a moment the improved workflow, but I want to go in depth into some of the problems that we had. So the ways that you can do it wrong are keeping your YAR rules on a file server. First of all, that's not where YAR rules belong. Having them on some person's laptop, and then that laptop gets lost because they've been working on rules over the weekend or something like that. If you have it spread across lots of people's laptops, all of these are the wrong way to do it. And then also for working with AMAs, downloading files from one thing and uploading something else is also totally doing it wrong. And I lift things and I put them down. I lift things up and I put them down. So you don't want your analysts doing that. You don't want them waiting for AMAs to finish. You want to have everything queued up in advance. So this is the improved version, and I think some people will recognize that there is one key piece that's still over in the analyst's swim lane here, and this is because VirusTotal doesn't have a way to upload YAR rules via API to their hunting system. That's a request that I made long ago, which hasn't been satisfied yet, but if anyone out there will, anyone from VirusTotal's here, go ahead and take this as a feature request. So you download the rule sets from the hunting system, which was a feature that I did request and they did put in. So the ability to download your rule sets, you're welcome. That's a feature request I put in years ago. You then have the hunting system where VirusTotal looks for different files that are submitted, and if they match one of your rules, you get a notification. So we have a notification prioritization system, which I'll go into in depth in just a moment. But you then have to take any of the files that you're alerted to, you have to download them from the VirusTotal file repository. So this is all done automatically. And then it's all sent into the sandbox. You've got the sandbox results after a certain period of time. And then the sandbox results, along with the notification and the file and any other tools that you have available, are all just presented to the analyst, and they can do their work. And all of this gets done constantly. Some pieces of this process occur in the morning so that our team can get their work done immediately. So the stuff is all batched out in the morning, and then they have a number of things that they can look at immediately. So doing it right. One of the things you need to do is keep your rules in a revision control system. I'm not telling you to use Git. If you like Subversion, if you like, CVS or something ancient, that's okay too, but keep them all in revision control. That's where rules belong. I especially love the git blame feature. So, if you've got a bunch of people working on rules and something changes and all of a sudden you're not detecting something that you think you should be, you can figure out in Git to find blame as to who it was that checked that thing in. So these things are good. Git blame is great. But this also lets you have deployment scripts so that when you do a commit, when you check in that code in your revision control, you can also kick off a script that can be, and if you think about it, you're basically using the same paradigm that web authors use, where they do deployments and changes due to commit log messages that they add. And so commit log messages can kick off a process. And so the process I'm using here is that it deploys the rules that were changed into whatever Yara hunting system you're using at that time. So it also allows you to sync your information with the threat intelligence platform. Of course, I work for one, but you could sync it with MISP or any of the different various threat intelligence platforms. I know I'm deep in MISP territory here. So this is actually a little bit of the changed format, not necessarily format, but kind of abuse of the format that I'm using for doing prioritization and other things. So there's a couple of details. It won't be obvious here what I'm doing, but I'm using the meta section to assign priority and confidence to each one of the rules that we've got deployed. This way, priority, and I'll go in depth into what I mean by priority, but it should be obvious. It's how important this rule is for your organization. And then confidence can be, judged over time as to how good of a rule it is, whether it's high in false positives, or when you first deploy the rule, it's basically the gut feeling of the analyst as to how good of a job they did writing the rule. Sandbox restricted, obviously, because you're using automation to take rules from, take the output of rules and add that to sandboxes. Many automated malware analysis systems can only handle certain file types, and then there are other file types that you might be hunting for that you would never want to sandbox. Like you would never want to send a CSV file or a text file to a sandbox. That would waste the resources there. So you can apply sandbox restriction to the rules. And then there's another really interesting detail down there on the conditions. So I don't know if any of you deploy rules to VirusTotal or use Yara on your own, but VirusTotal has its own condition language. And so what we do is actually split the generic Yara language for conditions and the VirusTotal onto different lines, so that the automation that we use to build the Yara rules that go to someone's analysis system that they're using locally, as opposed to the analysis system that they're using at VirusTotal, you can strip out the VirusTotal specific conditions in an automated way, and you can have one repository of rules that get deployed in two different ways. So, one of the things you get from this is, you can get associations from a particular signature out to different files that have been caught by this particular signature. This is a pretty recent one. It's a Xman PDB, and these are some files that we actually caught with it. We'll have a little bit more detail in a moment. But I want to pause here and say that one of the tools that I've been using recently, I found this sort of semi-abandoned library called Plyara, and it uses Ply, which is David Beasley, DaBease's Python Lex Yak. So it's Lex and Yak that has been implemented using Python, and so this uses Ply to parse VirusTotal, any type, not just VirusTotal, but any Yara rule format. And I actually had a discussion with some of the maintainers of Yara Python, and one of the and I know that Yara Python can parse Yara rules and then provide you with the same information that I get from PlyYara. However, it can't handle the VirusTotal specific conditions. And so this PlyYara I found can do it basically handles everything. I had to rewrite it almost from scratch, but right now, this is the upstream of it. I have a fork of it on my GitHub, and I've actually been in discussions with this project's father for custody. And so the custody battle hasn't ended yet, but I will get permission to upstream all of my changes to the main repo probably over the weekend. So keep an eye out for the changes that I will be checking in very soon. So I want to pause here and highlight something because I know a lot of us work with open source software. Open source software is a really, really good thing. I love open source, but I want to behoove everyone to be good open source citizens. So this is an example of good open source citizenry. This is actually taken from Netflix's Open Connect Appliance information page, and it's highlighting that they use FreeBSD for all of their servers. And so I want to make a point here. So all code improvements, feature additions, and bug fixes are contributed directly back to the open source community for FreeBSD. So they don't keep any of these things to themselves. And if you've got something that you're using and then you've forked it in GitHub and then you've made wonderful improvements to it, why not take those improvements and do a pull request and send that stuff back to the original project? Please do that. Don't keep your wonderful changes and improvements to yourself. So end of that aside, and I'm going to show you what PlyYara does. Hopefully that worked. All right, good. The demo gods are smiling upon my presentation. So as you can see here, this is just one particular rule set. And so what it does is it breaks the rule. It breaks a particular rule. I've got a lot of rules in this one rule set. This is actually our Russia focused rule set. But this is one of the rules, the Turla rule. And so as you can see, it shows you all of the condition terms, and it basically, PlyYara coughs up a Python dictionary, which can then be dumped to JSON as you like, or used however you want. But it shows you all the condition terms. It then shows you a separate section for the metadata. And here we've got, the sandbox restriction for this one is false. This is a high priority. This is another key for my team. It's whether this rule is destined for our Intel product or not. And then down at the bottom, you've got, this is something I actually added to PlyYara. It didn't actually give you the start and stop lines, but it's actually very valuable when you're looking through and editing a larger rule set to know where that particular rule starts and stops. So I've given you the start line and the stop line so that you can go directly to where your rule exists in your file. And then it breaks out modifiers breaks the strings out into the modifiers and then the various strings. So you've got the name of the string that you're looking for, the value, and then the various modifiers. So outside of what I'm using PlyYara for, I would recommend it for a lot of other purposes. You could use it for linting your rules. You could use it for making sure that you could ingest rules from somewhere else. And if you've got a particular, if you like indentation in a certain way, you could have it output in your way. And so there's lots of different things you could use this for. So I encourage you to check it out. So, and by the way, this is a plug for another favorite open source project I have. I know I was in the workshop here on Tuesday, so thumbs up for using Jupyter in the workshops. But yeah, Jupyter is really awesome. What you just saw there is notebook programming via this product called Jupyter. And so notebook programming is somewhere in between a REPL, and REPL, by the way, is the medical term for when you go to the command line and you type Python or Perl, the thing that you get at that point is an REPL. And then it's notebook programming is basically somewhere, some happy medium between an REPL and a monolithic script that you have to edit one piece and then rerun the whole thing. So back to the core of the talk. So the idea here is to take the data that's coming out of your hunting process. You know, you've got a whole set of rules deployed, and then the result of that rule is a match on a file. And so you want to have a prioritization queue. And so what you're seeing here is this is a JavaScript that my team has whipped up for, basically ordering the output of our various rules. And I'm going to show you, I promised that I would show you some of the gotchas and problems that we've identified. So this is actually, this particular queue right here has a problem that we've identified, and I'll show you one of the solution that we've got for it. But you can see over here that there's a lot of things that are generic, and that run right in the middle is probably one that our team would be very much more interested in. So the APT PRP in there in the middle, that's a very, very important one for us to look at. But these other ones are basically TTP or general signatures, which are also very rich in finding bad things, but they're probably not as high of a priority. So one of the things that we're implementing is a lottery queue. So you have one team looking at, or you have the team. No, we don't have two teams. You have one team looking at the output of the very targeted rules, APT, malware families that are very specific, or very specific threats. And then there's another queue of the lottery queue, which is the TTPs and stuff like that, which is kind of a grab bag where, in between working on something which takes you a lot of time, you just go and grab something from the grab bag, which could be something very new. You could discover something that we haven't seen before, but you basically have a lottery queue where you spend some time just trying to win the lottery. So one of the things that we do after we've got the rules prioritized is, in addition to the high priority and high confidence and on down, there's scoring. And so, we have our own scoring and weights for these different good and bad things. But what I would encourage you to do, and what we think of as good and bad might actually not match up with the right thing for your organization. But what you should do is make a list of the things that you would want to add points to your finding or subtract points to your finding, and then you assign weights to each one of these. And that way you've got a calculated weighted score that you can apply to each one of the files that match your YAR rule. And at that point, you can then order the output in by the score, and then you could have your team picking things off from the top of that queue. One of the other things here is we've discovered that there's a bit of non-intuitive ordering that you need to do. And the non-intuitiveness is that instead of having it go from high, medium, high, low, et cetera, we actually bumped all the low confidence kind of noisy garbage rules all the way down to the bottom. And this actually saves time and effort. And it hasn't really affected our overall process. And this has actually improved the amount of garbage that ends up taking up someone's time. So one of the things, and this is where we're going to hit some of the more business end of stuff. So you need to have a prioritization meeting, and you have to have your prioritization meetings frequently. So our team prioritizes stuff week to week. It depends on what your organization is and what you're looking for, but you should have a frequent prioritization meeting where you review what it is that you're looking for, what's important for your team, what's important for your organization. And then last of all, you need to automate your AMAs. I'm not going to go into detail about automating specific ones, but these are ones that I personally have automated myself. I'm familiar with the API of all of them. And so actually, if you have any of these and you want to implement my process, please contact me. I can help you with some of the idiosyncrasies of all of these various AMAs, because every AMA is kind of like its own little snowflake. So future work that I would like to take on with this particular project. So in addition to those two values that we saw earlier, which are priority and confidence, I have a hypothesis that we can add another value, and the name of it doesn't really matter. I've just chosen business value. It could be effectiveness or whatever you want to call it, but a third value. And my hypothesis that this third value can be, we would have to toy with how much weight it gets in the process, but it can be completely automated. So what you would do is choose all of the different, steps in your process which you can measure the rule's successfulness. This actually might be different for your organization. So if you're just defending a network, the business value of a particular rule may be it effectively blocked something, or it effectively found something that would not have gone detected otherwise by a different system. So these particular steps in my business value are for my team. So I would encourage you, once we've got this worked out and I've done a little bit more exploration in here, you would want to choose a different set that are tuned to your particular organization, and then give them a scoring weight, and then have that weight, calculate a business value of low, medium, or high, which can then be included into your prioritization process. So just to explain these for my organization, my team, there's basically a pool of data coming out of the Yara hunting process, and then the analysts can claim parts of it to analyze. So one of the steps would be whether the output of a rule was pretty enough to be claimed by one of the analysts. And then the data set gets analyzed, so whether the analysts looked at it and said, this is garbage, and then just moved on, or whether they began actually analyzing that particular output. And then once they've analyzed the output, there is a point where they might go again, this is not really important, or this is a complete false positive, or it's garbage, and then they threw that away. But the other option is they've published that into an intelligence product. And so, publication of that as intelligence is another, plus X for that particular calculation. And then further from that, there's the possibility that this is important enough for it to be shared widely via blog post, or shared in our common community inside of our threat intelligence platform. And then you've got, perhaps this in our case, drove a new account to be created in our system. And then, the holy grail would be that you can actually kind of trace the Rube Goldberg drawing of our intelligence process from a Yara rule out to a new customer. So that would be the holy grail of business value for us, at least. So also, one of the things that I encourage when you implement a process like this is keep your bean counters happy. Being able to maximize the movement of data from collection to exploitation. And when I say exploitation, I don't mean exploitation in the terms of exploiting a vulnerability. I mean exploiting the data and turning it into information. And then you need to collect metrics on your utilization. So this is extremely important when budget time comes around, because I know no one in this room has an infinite budget except for maybe the folks from Google. And so the rest of us that don't have an infinite budget, you have to prove that you are using your resources effectively year by year, so that your bean counters will say, okay, I agree, you need more resources to the tune of money. And so what you need to do is, first of all, prove to them that you're using things like an AMA at maximal capacity. And the way you can do that is making sure that you automate the data going in, and then basically pushing the most amount of data to your AMA that you've got the resources for. And then when you cap it out, you can actually keep track of your utilization statistics and come to your bean counters with a nice graph saying, look, we're at maximal capacity, and then if you give us this more money, we'll be able to add more capacity to the AMA, and we'll be able to handle the load that we've got coming in from collections. Also, there's a term in here, so you need to establish KPIs, and I know I'm getting really into the management speak and the business-esque stuff, but you have to do that. We are in a business. So KPI is a key performance indicator. And so automating everything in the way that I have talked about here in this process leads you to being able to develop key performance indicators. So a key performance indicator is something that can be measured on a schedule. So it might be measured every day, it might be measured every week, but it's basically a number of some kind that you can put up on a wall, and you can say, oh, hey, like the work that I'm doing now, as I do better work, it's actually shifting that like dial towards green or whatever it is that you're using as your KPI. So KPIs are important, and it's very, very important to gather statistics about the different stages of your process and apply KPIs to each stage so that you know whether you're being successful or not. So one of the other things is where you get your samples. And so like I said, my team hunts in different locations, one of them being VirusTotal, but that's not necessarily where this process is required to be applied. A lot of us are defending a large organization, and so there are other places where you can apply a Yara hunting process. I've seen Yara spoken about in many of the talks this week, and that's really awesome. But I can tell you some of the places where you want to get data from your own network. So I use Bro for carving files out of network capture. It is fantastic. I love Bro. Check some of my other talks where I go in depth into how to use Bro for malware analysis and not necessarily for network intrusion detection. But I would encourage you to look those up. Also, you can look at incoming email attachments. So if you have some sort of system on your mail server which is pulling attachments, that stream of samples can also be put through this process. Endpoint collection, I know that AV quarantine, you can get back quarantine from your endpoints. If you have something like a Carbon Black, which is actually pulling any file it doesn't know about, all of these different streams of files can all be funneled down into one queue, and then that queue can be processed with Yara, and then the output can have the prioritization system that I've described here applied to it. And then you could have a small team of people looking at the output of this and hunting for things that, and from my perspective, my team is hunting for new, interesting things that we can, either publish publicly, et cetera. But your team might actually only be interested in, the adversaries that you have modeled during your threat modeling, and I hope you do threat modeling. So once you've done threat modeling, you might be able to narrow the things that you're looking for down to the possibilities of what you think will actually be attacking the resources in your organization. And so that could be part of your prioritization process. And then at the speaker dinner the other night, we actually had a laugh because one of the other, and this was in the talk before we spoke the other day, but so CCleaner. I know we heard the story of CCleaner, and so you can also take your supply chain, so the files that you've got in your supply chain that, you might trust them, but why not funnel them in? So there's I'm talking about a process that can take a large volume of files and narrow it down to something that is manageable for a team. So including things that you think are safe from your supply chain is a good idea to add to your hunting system. So I want to go over a few success stories that my team has had recently. And so this is Casper Agent. this is a implant that leverages, fake documents, and I'll show you in just a moment what one of those looks like. But this is, and this was one that was discovered by Palo Alto, Clear Sky, et cetera. But we actually took some of the information from those earlier discoveries and then deployed a set of YAR rules that we had built based, based on the files that had been discovered before, and found, it was sort of like knocking a hole in the wall and finding a whole bunch of cockroaches back there. So we find, a whole raft more of these attacks. And, as everyone has said a couple times this week, attribution is hard. So this particular one, I'm not going to attempt to attribute it, but there's a theme with the documents that you'll see. At least you can see the victimology here. They're going after people that are interested in Middle East political affairs, Palestinian Authority, Israel, etc. And so this is one of the documents. And by the way, this is not like a secret document. We did check before we published any of these to see if they're available on the open source already. So none of these documents that we've published are not already available just by doing a Google image search. And that's actually probably exactly what the adversary did as well. They probably did a Google image search, found things that they thought were good bait for their victims, and then bake that into their malware. At the same time, you can go and look at, oh, this didn't load. Ha! That's a great success story, blank slide. So fail story in the slides, but so I'll just kind of describe what was there. It was a Maltego drawing, a Maltego graph of something that is very generic that we found, but is fairly important. Let me see if I can actually get that to reload. It's not going to reload. All right. So either way, that was one that I added this morning. So it actually, let's see, what does it say? Try reloading to reload. No, it's not going to reload. All right. So moving on, this is another success story. So I've been tracking a particular adversary, Z556677, for quite a while. This adversary began years ago, spreading Alina point-of-sale malware. And over the years, the hunting system that I've been using has been feeding me more and more information about it. And then finally, myself and a couple of colleagues, we actually had some breakthrough in this because the amount of data that I had collected over all the years about this particular adversary kind of added up to the point where we could say, all right, we've figured out like this and these patterns, and then finally had a breakthrough where one of the email addresses that the adversary used to sign up for their Twitter account actually had, so the Twitter name was let's see if I get this right. So the Twitter name, it's Morelith here. So the Twitter name had another associated Twitter account, and that other associated Twitter account, the name of that account happened to be a password that showed up in, well, actually not the exact thing, but it was a variation of the password in the MySpace dump. And this was fascinating because, if you take the information we had here and we found that password in the MySpace dump, and then lo and behold, back in the day when this adversary was using MySpace, this was before they had kind of ratcheted up their OPSEC, and they used their personal email address. And so we got their first and last name, personal email address from the registered email address from the MySpace dump by going backwards from the password. So, that's an interesting success story. It's not directly related to our hunting process, but the sleuthing that occurred wouldn't have happened if I hadn't been collecting this body of information over the years using our hunting process. Looks like we've got about 8 minutes left. I got a couple more slides. So some of the 10 minutes left, good. All right, so some of the key takeaways here that I'd like you to have are making sure that you organize your signatures in revision control. And this doesn't necessarily apply to only Yara signatures. If you've got bro scripts, if you've got various types of signatures, if you look at them, they're text and they look like code, treat them like code. They need to have revisions, keep them in a revision control system. Also, make sure that you apply automation between systems in your tool chain. Don't make your analysts take the output from one thing and then pivot to another thing without some form of automation. Don't make them work in that way. Also, one of the other takeaways, and this is a more recent one that we've kind of come to the conclusion of, is have separate queues for signature type. So if you've got attack pattern queue, if you've got attack pattern signatures or TTPs, and I'll give you an example of this. So the file ending is pdf.exe. So that's a very generic sort of attack pattern type of signature. So you want to have those separated from your malware family and your adversary-based signatures so that you can have two queues. And the one that I kind of call the attack pattern queue, the lottery. So it's kind of a grab bag as to what you're going to get. And then you want to have remember to have periodic prioritization meetings. And then this is not even like a security takeaway. This is just one of those things that I want to hammer home. When you're making changes to an open source project, send your changes upstream. Send them back to the people that wrote the project. Make sure that and that's the best way to share your wonderful patches to the code. So I hope that if you implement this particular process, you don't end up like this. And I hope you guys watch It's Always Sunny in Philadelphia and Charlie. But yeah, this is when he found Pepe Sylvia. So thank you all. It's been great this week. And if you have any questions.
Thanks, Robert. Are there any questions? Nope. Okay, thanks.
Thank you.